let's talk about this problem of integration and sort of legacy systems. Because we're now playing video out over systems that were never intended to have video over them, or indeed over systems that were, in the case of US cable networks sometimes, but are now quite old. I mean, just how massive a challenge is trying to run T&M over a whole mixed bag of legacy equipment?
Well, I come across quite regularly where there are lots of small operators. Typically, the manufacturers providing the compression equipment, they normally carry the complex equipment for testing, and so the installation is carried out correctly. But further down the chain, there are some issues. They may not have a monitoring installed on day one, so they don't have any way of monitoring. But time to time, there are some intermittent issues, and they need to find what the problems are. Typically, the manufacturers will send back an engineer across the continents to measure and monitor and take a recording or something. Now we're finding a lot of the manufacturers are introducing the operators to simple low-cost tools which allow them to take the recording. So when there are intermittent issues, as a bare minimum, take the recording, basic analysis if they wish to. Otherwise, at least the manufacturer can repeat the test back at base to ensure those problems do not occur again.
But as I understand it, Tollgrave, for example, has come in more from the telco side, if you like. We've got established companies who've been in the broadcast signal monitoring business. We've got people in the head-end business. We've got people in the CPE business. It must be a real challenge to try and map a T&M that's going to cover everything. And as I understand it, almost no suppliers actually do that. So you guys must have to work together, presumably, at some point.
Yes. There's a great deal of collaboration that's required at the moment. And one of the reasons for that is test systems, in particular test systems that apply to the access network, have traditionally been built around the concept of distributed probes and test heads. And with the introduction of much of this equipment I spoke about before, there are also, in addition, new testing constructs, many of them driven by standards, that are available through the embedded chipsets or through the actual access equipment or through the CPE. And it's in addition to the test probes and test heads that are mounted somewhere in different points in the network, there are things like MIBs, Management Information Base, SELT, DELT, MELT, which are standards-based chipset type of testing. There's managed CPE, TR-069, and so forth. All these forms of testing, in many times, can be multiply applied to the same port or the same line. So it's the challenge of the test and measurement system to acquire as much of that information that's available on a particular port or line, integrate it, and make sense out of it. Many times the data can be in conflict, many times the data can be missing, but somewhere in there, in the management and the integration of all of that information, is an analysis that leads to a fault identification, a fault location, and supports things like reduced truck rolls, reduced mean time to repair, reduced call handling times, and those types of things.
Is bringing all that information together and presenting it in a way that doesn't take massive investment in training and all the rest of it a big issue too?
Oh, absolutely. I think that's one of the real big challenges that we're seeing, is that now that you have multiple points of monitoring that you look at, multiple points in the network, especially due to the complexity, you have all this information coming back also from devices out in the network, and they need to quickly sift through that information and come up with a root cause analysis. And the one thing that we've done to help in that effort is we've basically took all the audio and the video metrics that we're analyzing deep into the source and came up with a one-score metric. And we're starting to see that more and more with some other standards that are coming out. Because what people want to know is, I don't know enough about IP, I don't know enough about MPEG, I don't know enough even deeper than that in the audio levels. Just let me know, is it going to affect my customer or is it not?
So it's like a scorecard of how bad it is.
Exactly, and it's similar to what you see in the voice side with MOS. It has some similarity to those standards, but again, it comes down, all right, if I see a certain score below a certain point, let's say 75 out of 100, I know what my set-top box is going to start tiling, or I know that I'm going to start dropping audio packets based on those metrics. I don't need to know anything more about MPEG. I just know below 75, I need to do something.
Is that something that you guys are trying to head towards as an industry-wide standard, or?
We would like to see obviously we'd like to see our methodology go to the industry standard, sure, but I
does
think
Darren have a different one? And
No, we do actually. We have a video MOS score, a VMOS score. You know, as Rob says, you know, we take lots of metrics, combine them from, you know, IP, transport, MPEG type things, and basically jumble them up and give a score to your field technician. Okay, so these guys who've been working on voice for the last 10, 20 years, you know, they're not IP experts today, but they need to be able to solve and resolve these problems in the house.
And this gives people kind of a red, amber, green type of readout.
It's very similar to in my field at the right end of the actual installation process. You have a big demand of X amount of engineers who's going to go out and do these installations. Take India, where some of the broadcasters are going to install 6 million customers in 2 years. There is not enough engineers for that. Yeah. So you have to find, especially if you take, again, I'll go back to satellite, you need someone who's good on a ladder, who's a window cleaner, who can stand on the ladder, but he knows absolutely nothing about the signals, about the MPEG stream, bit error rate, FEC, all of this sort of things. So we got our own logarithm where we differentiate ourselves from the competition. We have a percentage scale, where we have all the clever things happening at the back end inside the instrument, and he needs to know that he needs to get the maximum percentage he can all the time. Yeah. And that simplifies the process. So it's very similar to the issues the industry as a whole has. You will find it more and more increasingly difficult to find somebody who actually understands the information they get. So you need a traffic light type of scenario. And
so that's on the sort of diagnosis side. Can you achieve similar things on the kind of fixing side in terms of almost sort of point and press type technology at that end?
Yes, as a matter of fact, maybe to build on the point here, the red, amber, green type of indication is all important as a first indication, but there needs to be follow-on information as well. A green indicator needs to be comprehensive, such that if there is still a problem reported, even under a green condition, that can only mean one thing, and that the problem isn't in the particular network or portion of the network or service that's being tested. In other words, to the technician, to the customer service representative, look elsewhere. Pass the problem back to someone else that owns it. That's all important follow-on information from the green. On the red side, doesn't work, need to have fault location information. Where do I go to fix it? That in turn reduces mean time to repair. It reduces the additional truck rolls, the dispatch to find rather than dispatch to fix. So the level of analysis and the complexity is more than just converting to red, amber, green. It's also the follow-on information that allows the continued resolution and the true closing of that trouble.
Well, the cost is the key thing to make it more affordable, and I mean that's a factor which drives the industry as well, very much so.
In terms of the commodity cost of the equipment and the training and everything that goes with it?
Yeah. It's just not the equipment, it's the training, how easy is it to use, what does it actually give you back, etc.
But I mean, you know, we touched on right at the beginning. I'm sure you guys would probably agree that it's not ranked high enough in terms of budgeting, in terms of what the real cost and benefit is, particularly when it comes to things like QoE, and how that then feeds on to renewals. You know, when we're talking about pay television.
Well, that's one thing that we're trying to communicate and drive is relating the proactive monitoring to some kind of return with OPEX or with reductions in mean time to repair and how that affects their bottom line. And you're right, that's challenging at times, but we're starting to get some real good results. We're starting to capture some information, and you know, our goal is to be able to have some kind of payback within 6 months. And so that includes not just the cost, but also making sure that it's easy enough to deploy and it's easy enough to use, because that way people are using it very quickly and they're starting to fix problems, they're starting to reduce their OPEX, reduce their truck rolls, and starting to get their benefit back. But it is a challenging sell.
I think the payback is very easily to prove on test equipment, and the engineers you speak to who understands what you're trying to sell them or whatever, dead easy. But to get that to the management level, to the board level, and then to get them to understand it. And we spend a lot of time in helping our sort of technical departments and broadcasters for them to present it to the board level.
Yeah.
But there are other, it's about the sexy content, what's the revenue stream is, how many customers can we have? It's never the test equipment, never comes into it. So that's a challenge to overcome.